I want to take some time to introduce a slightly new idea on this slide. Up until this point, we've focused on model evaluation. And specifically, we've assessed our models using a performance metric. Now, this performance metric might be the mean squared error for regression problems or categorical cross entropy, as we've seen for classification problems. Remember, we want our models to generalize to new data. We want models that perform well on data that it's never seen during the training phase. And we call this good out of sample performance. But there are other aspects we should consider when assessing our models, and I like to call this model appraisal rather than model evaluation. Now, model evaluation is good, and we should determine which of our models have the best out of sample performance, but there are a number of other things we should consider before making our final model selection. So to illustrate this point, let's assume we have two models on this slide, one red model and one blue model. If we were choosing a model based solely on performance, we'd see the clear choice is in fact the blue model because it outperforms the red in terms of this performance metric. In this case, a higher score is better. But let's take a closer look at some of these other model attributes. We could consider a factor like trying to understand how a model is generating a prediction. We call this interpretability. We could also consider the latency or lag time between providing data to a model and making a prediction. Similarly, we could track the time it takes to train our models and use that as a factor in our model appraisal. So in this example, if we take a good look at this red model, we'd see although it is slightly less performant than our blue model, our red model is extremely interpretable. It's not very complex. It has a very low latency and prediction time, along with a short training time. So this slide serves as an example of model appraisal. It's not just performance that we need to account for. There are other considerations beyond the evaluation metric, like the model's interpretability, the training time, the model complexity. When defining what is considered a good model in the context of our problem, we should consider all of these factors. When we look at the full picture of each of these models, we may actually conclude that the red model, although slightly less performant, is the right choice in the context of our problem.